have completed studied the superposition theorem, and now again the next topic is Thevenin and Norton theorem. So before starting, we know that what is a practical voltage source? That is a resistance in series with a voltage, that is Vs, that is Rs, or it can be written as Vth. This can be written as Rth. This is the load terminal. This is load. Now we know that from the source transformation principle, a practical voltage source can be converted into its practical current source equivalent. So if we convert this into its current equivalent, what I will get, that is a current source Is, or is equal to In. There is a parallel resistance, that is Rth, or equal to Rn, or equal to Rs, and this is the load terminal. So by source transformation we can obtain the Norton equivalent. This is what Norton equivalent, and this is what Thevenin equivalent. Is it okay? Then in a linear network, from a defined load terminal, in a linear network from a defined load terminal, it is always possible to replace the entire network just before this terminal, the entire network can be replaced by its equivalent practical source or by its equivalent to a current source. If it is replaced by equivalent practical voltage source, then it is known as Thevenin equivalent, and if it is replaced with the practical current source, then it is known as what? Norton equivalent. Then in these two equivalent, the parameters are Vth, that is what? Thevenin voltage, or open circuit voltage. Next one is Rth or Rn, that is known as Thevenin resistance. Similarly, In, that is known as Norton current. Or short circuit current. Okay, so now we will discuss the procedures to perform numericals on the basis of Thevenin and Norton theorem. Then what is the step 1? Step 1, across the load terminal, find the open circuit voltage, and that is nothing but Vth, that is equal to Voc. Is it okay? Step 2, how you will find this? You will use basically nodal, mesh, or KVL and KCL to get this voltage in the network. Okay, now step number 2 is to find Rth or Rn across the defined terminal. Okay, now how to get this RTH and RN, there are basically three methods. First one is method 1. Conditions are the network must have only number 1 resistors, number 2 independent voltage or current source. If a network consists of a resistors only and independent voltage and current sources, then the RTH can be calculated. The RTH can be calculated. How? RTH can be calculated by making series and parallel combinations. Series and parallel combinations by replacing all independent voltage sources with short circuit and independent current sources with open circuit. So make series and parallel combinations and you will get what? RTH value. Now if I talk about for the method 2, what is the method 2? So I'm writing about method 2. What is the method 2? Method 2. It is applicable to network having dependent source or having independent source along with dependent source. That means in this method, what is the approach? If a network have resistance, dependent sources, and also it has independent sources, then this method is applied to get what? RTH value. How you will do in this case? The RTH will be defined as VTH divided by ISC. Let us assume this is the terminal AB. First find this VTH and what? Short circuit current by making it short, and take these two ratio, you will get what? RTH. This is applicable to any type of network. It is also note, it is applicable to all networks. That means if it is a purely resistive network having independent sources, or it is a purely resistive network only, or it is a purely resistive network with independent and dependent sources, anywhere we can apply this method too. But whenever you see a dependent source in the network and you have to calculate the RTH value, then apply this method number 2. Now the method number 3, what is this one? This is known as test voltage method. This is known as test voltage method. In this is applicable to all networks. So it is called universal method. That means method 2 and method 3 both are known as what? Universal method, as it can be applied to any network. What you will do to get RTH value, what I will do, let's assume these two terminals across which you have to calculate RTH. Okay, then take this terminal, connect the voltage source at this terminal. Let's assume this is Vx and this is the current Ix. Connect the voltage source Vx having a current flowing, that is Ix. Then RTH will be defined as Vx by Ix. How you will calculate this Vx by Ix ratio? By using number 1 nodal, number 2 mesh, and number 3 is what? KVL and KCL. All three things you can apply to calculate the RTH. So we have three methods. One is purely resistive network or having independent sources. Then second method is what? That is applicable to network having dependent sources or having independent sources along with dependent sources. Then you have to apply like VTH by ISC, and this ISC is also called Norton current, IN. Is it okay? Now the method 3, test voltage method, this is applicable to all networks, so it is called universal method, and RT can be calculated by applying a voltage source and finding the ratio of Vx and Ix. You will get RTH. But you have to very careful in applying method 3 while connecting this Vx and finding Vx by Ix in the network. Just replace all the independent voltage sources with what? Open circuit, and all the independent voltage sources with short circuit, all the independent current sources with the open circuit while applying this method. Otherwise you will get a wrong solution. Is it okay? So do all these things while applying the KVL and while applying the Thevenin and Norton theorem. So what I have discussed, that is Thevenin and Norton theorem, and both are just source transformation of a Thevenin equivalent into Norton equivalent or Norton equivalent into Thevenin equivalent, and you know how to do this source transformation. Okay, the basic approach is what? That is, first always find VTH or VSC across the defined terminal by using nodal, mesh or KVL and KCL, and next find the RTH across the defined terminal. And there are three methods. One is network having resistive independent sources, then just make series and combination by making independent voltage sources short circuit and current sources with open circuit, method 2 and method 3. Okay, so this is what all about what? Thevenin and Norton theorem. So let's do one example to see how this theorem can be applied. So I am taking this question, that is, see how I'm going to apply this theorem. Let's take this example. It's a gate problem. There is a dependent source. This is 1 ohm. This is again 1 ohm. This is a current source. this is resistance, this is terminal AB across which we have to calculate VTH and RTH. This is 2 ampere, this one is 2 ohm, this one is again 1 ohm, this one is again 1 ohm, this is 2 capital I, and I is what? This is I. Okay, so step 1, I've already told you, step 1, we have to calculate VTH. If you want to do calculation for VTH, what do you say? This voltage is VTH, this will be also plus minus VTH, this will be also VTH, this will be also VTH. So I can say that these three node voltages having a VTH voltage. Now just apply a nodal analysis. What I have told in nodal analysis, that take the node voltage VTH bracket all the self resistances, self conductances, that is 1 by 2 plus 1 by 1 plus 1 by 1. That's all. Is it okay? Is there any other node present in the network? No, there is no. That means minus, mutual is 0, 0. Is there any current source present? Yes, there is a current source present. It is incoming current. Take always positive. That is 2. Is there any voltage source? Yes, we have voltage source. Positive is connected to this node. Take it positive. This one is what? 2i divided by what? Its resistance is 1. Is it okay? So this one is first expression. We have a one expression and two unknowns VTH and I. We have to get a one more expression. We can do it. We can see here this voltage is VTH. This is plus minus what? VTH. Then I can be written as VTH divided by what? 1. This is expression number 2. So by solving 1 and 2, we can get VTH is equal to 4 volt. Just solve by yourself. Now the next thing is what? Step 2, to get RTH. See the network. Can I apply the method 1? No, we can't apply because there is a dependent source. Can I apply method 2? Yes, we can. Can I apply method 3? Yes, we can. So I'm going for what? Method 2. What I will do? RTH will be equal to VTH divided by what? ISC. That is the short circuit current. We can find this short circuit current by what? Making it short circuit. What I will do? This is dependent source. This is resistance. This is also resistance. Current source. This is again resistance. I have made it what? Short. And I have to calculate this ISC. This is 2 ohm. This one is 1 ohm. This one is 1 ohm. This is plus minus 2i. And this current is what? I. Just see in the network what you are getting. This is shorted terminal AB. If it is shorted, it is also shorted. This one is also what? This current source. This is a dependent voltage source. This is depending upon this current. This current source 2 ampere will flow through the shortest path. Is it okay? If this current is flowing in this path, that means this current will be 0. This current will be 0. If this current is 0, this will be 0. 0 volt means this is also shorted. What I will get? What I will get? I will get ISC is equal to exactly 2 ampere. So if we know the ISC value, we can say that the RTH is equal to 4 divided by 2. That is equal to what? 2. Is it fine? So by doing this, we can say that the Thevenin equivalent will be, this is plus minus VTH RTH. This is AB terminal. This is 2 ohm. This one is 4 volt. Now if it has been asked about Norton equivalent, we can get it. This is ISC. ISC will be what? VTH divided by what? RTH. VTH is 4 divided by 2, that is equal to 2 ampere. And already I have also calculated this ISC is equal to 2 ampere. What is this? This one is RN. RN is how much? That is equal to RTH. This is 2 ohm, and this terminal is what? AB. So this is what? This is Thevenin and Norton theorem. how you will perform all these indices. I'm not doing so number of problems in this session. We will do in a separate video lecture all the problems related to network theorems very soon. Is it okay? So just subscribe this channel, and if there is any doubt, just post it on no problem Facebook group. Thank you very much.